So we'll finish out this section doing the last few. I'm going to go ahead and rewrite this one. So what we have is the limit as x approaches 62 of the square root of x plus 2 minus 8 over x minus 62. Okay, so this is what we're starting with. Now, hang on, let's try and organize. All right. So this is what I'm starting with. Direct substitution, if I shove in a 62, 62 plus 2 is 64, and its square root is 8. So 8 minus 8 is 0. 62 minus 62 is 0. So I have 0 over 0. So what we're going to do is called rationalizing, and you probably remember rationalizing the denominator. So pause this problem for just a second. When we used to rationalize denominators, let me go to scratch paper for a second. For instance, if I had 1 over the square root of 2. Okay, that should kind of sort of make your skin crawl in a math class because you don't want a radical in your denominator. And so what we would do is we would multiply the top and the bottom, because now I'm just multiplying by 1. So I'm not changing what it is, I'm just changing what it looks like. And then the square root of 2 times itself is 2. So this is equivalent to this. It's just this is more proper. Okay, this is more proper to write it with a radical in your numerator. Now, that being said, my radical is in the numerator, which is where I want it to be. But because I'm in a situation, I'm going to try something. Nothing's going to reduce out. I can't factor. I can't do anything like that. So my next strategy is going to be to rationalize by the conjugate. So this is a term minus 8. So its conjugate is going to be the term plus 8. Okay, so I'm going to multiply by x plus 2 plus 8, square root of x plus 2 plus 8 on top and bottom. And the whole point is to get this in a position where I can start reducing and see what happens. And remember, for it to be able to reduce, I need multiplication on the top and the bottom. So I say that to say this. I'm going to FOIL the top and rewrite. So I've got the limit as x approaches 62 of a root times itself, means the argument pops out. Okay. And then I've got 8 times this thing. And then I got negative 8 times this thing. So my middle terms, when I'm foiling, are going to reduce out. And then I'm left with a negative 8 times a positive 8 is going to give me a negative 64. So when I fix that, I end up with an x minus 62 over, and I'm not going to FOIL this out because I'm trying to get something that's going to reduce out. So I'm going to leave this as an x minus 62 and a root x plus 2 plus 8. Okay. So when I do that, what just happened miraculously, and again, this is kind of a weird situation because it's set up perfectly for this to happen, but you're learning the strategy. Okay. So this is just another way to get around the thing of, oh, this just blew up in my face. So anything divided by itself is 1. So my new limit is going to be as x approaches 62 of 1 over the square root of x plus 2 plus 8. Now can I use direct substitution? And I can, because if I shove in a 62, I get 64, and the square root of 64 is 8, which means I get 1 over 16. So again, that's a new strategy. So basically, if I see radicals, I'm going to try and rationalize and see if I can make it to work that way. All right, so hang on, I've lost my paper. All right, so we did this one. Now on 17, and we're going to hit this up a few more times, but what I want you to notice, and I'm just going to mess up this one thing one time and then I'll fix it. So this is x plus delta x. Well, what does delta mean? Delta usually, you should kind of sort of realize, means the change of. So I've got x plus the change of x, and I'm going to square it. So if I write that out, meaning that delta x is a singular term, okay, that means when I FOIL it, I'm going to get x squared plus the o and the I of FOIL. So let me write it this way in case it's been a bit. Okay, so I have delta x. So x times x is x squared. X times delta x is x delta x. X times delta x is x delta x. Plus delta x times delta x is delta x squared, where you'd have delta squared and x squared, but really you can't do that because you're not doing delta. Delta isn't a thing on itself. So this is actually delta x squared. And then this would end up with 2 x delta x's. So if you will see, this is why I'm changing this. This is already a nasty mess, and I haven't even really started the problem yet. Okay, so what I'm going to do is everywhere that there's a delta x, I'm just going to put an h. Okay, I will put an h, and that's going to make our strategy a little bit easier to use. Okay, so just recognize, as long as you don't use it in the answer boxes, you'll be fine. I'm just trying to make it easier to see what we're doing. So what I have is the limit as delta x goes to 0, but remember I'm changing that to h. So I have the limit as h goes to 0 of, and then I've got x plus h squared minus 3 times x plus h, and then I have plus 9, and then minus x squared minus 3x plus 9, okay? And then that is over delta x, which we're going to make into an h. Okay, and it just makes it a little bit cleaner because it was already overwhelming. So you're going to find out that if h is 0, you'll have x squared minus 3x plus 9 minus itself. And so you'll have 0 on top and 0 on bottom. So what is something we know how to do? I can FOIL this thing out. I can combine like terms and go from there. So I have the limit as h approaches 0 of, we already decided that this is x plus h times x plus h. So that is x squared plus 2xh plus h squared. Then I have minus 3xh minus 3h, or sorry, I just said that wrong. Minus 3x minus 3h plus 9, and then just change the signs after that. So minus x squared plus 3x minus 9, all over h. Okay? So, sorry. All right. What I want to do is see if anything reduces out. And so I got an x squared here, and I got a negative x squared here. I got a negative 3x. I got a positive 3x. I got a negative 9, and I got a positive 9. And nothing else reduces out. So, but what do you notice everything in the numerator has? Everything in the numerator has an h. And so I'm going to reduce out an h. So again, I'm going to kind of sort of take my time on this one so you can see what's going. But I'm going to factor out an h on top. So factor it out here. I get a 2x plus h minus 3 all over h. So I just pulled an h out of everything in the top. And now I've got any number divided by itself is 1. So in future problems like this, I'm just going to say kill an h. Okay, kill an h out of every term because every term has 1. Well, now, can you take the limit? And so it's kind of confusing because I got some h's and I got some x's and I got some numbers. You'll just do exactly what it says to do. Wherever there's an h, you're going to put a 0. So this thing goes to 0, and what you're left with is 2x minus 3. Okay? So we're dipping our toes into differentiation. And this is actually called the difference quotient, but I'm going to show it to you in a couple problems because it's written out better. But I'll explain then what it means. All right, so let's try another one. We have a trig one. So I've got the limit as theta goes to something, goes to 0, of cosine of 8 theta times the tangent of 8 theta over theta. So just remember theta is a variable. Okay, nothing precious, nothing whatever. All right, so the cosine of 8 theta, if I shove in a 0, is going to be the cosine of 0, which is 1. The tangent of 8 theta, shove in a 0, it'll go to 0, so the tangent of 0 is 0. So I have 0 over 0. So what's something I know how to do? Well, there's no reducing to be done until I remember that tangent is the same thing as sine over cosine. So I have sine over cosine all over theta. Well, what is any number divided by itself? It's 1. And now look at this lovely thing that just popped up. You're going to have the limit as theta approaches 0 of the sine of 8 theta over theta. So what have we learned? This is 0 over 0. Do you see a coefficient in your numerator? I do. It's an 8. Do you see a coefficient in your denominator? I do. It's a 1. So your answer is 8. Okay? So that's just one of those little things that's going to pop up and scare you. All right, so I have the limit. I'm trying to not make this a long video. Of as x goes to 0. So the limit as x goes to 0 of root x plus 5 minus root 5 over x. And again, if you use direct substitution, it's going to go to pot. So what's our strategy? I'm seeing it's not reducible now, but I bet I can multiply by the conjugate and try that. So I'm going to multiply by root x plus 5 plus root 5 on top and bottom. Okay, so when I do that, remember you're going to FOIL across the top. So root x plus 5 times itself is x plus 5. Then you'll have a positive root 5 times this and a negative root 5 times this, so they'll cancel. And then a negative root 5 times a positive root 5 is a negative 5. Okay, because the 5 pops out and it's a negative answer. And then over, I've got x times root x plus 5 plus root 5. Which means what I actually have is x plus 5 minus 5. That goes to 0. Any number divided by itself is 1. So this thing just reduced to x plus 5 plus root 5. So what do I have for an answer? If I shove in a 0, I'm going to get root 5 plus root 5. Well, that means I must have 2 root 5s. So your answer is 1 over 2 root 5. Now here's a little secret. Don't tell anybody. The higher up you get in math, we acknowledge that you should rationalize, but we usually don't. Okay? Just because we're like, oh, hey, you can do that. So I'm not going to bother rationalizing it. WebAssign will take it as correct. So, all right. So last one that we're going to do, actually 2 more. And I'm going to squish this in 2 minutes or less. All right. So we have my function is 4x squared minus 2x. And I want to plop this thing into the difference quotient. So it says the limit as delta x goes to 0. So I'm changing it to an h of f of x plus h minus f of x all over h. So what you need to realize is that this is slope on steroids. This is y sub 1. This is y sub 2. And then over x sub 1 and x sub 2, which it doesn't matter what the subs are. I said it backwards. This is y2 minus y1 over. If I do my x's, I'll have x plus h minus x. There's x2 minus x1. So what happens when they reduce? You're left with h. This is slope on steroids. All you're doing is slope. Okay, but we're going to put it in this parabola. So what I have is everywhere, I'm going to do this part first. So I have 4x plus h squared minus 2 times x plus h minus, so that's this part, minus, rewrite the function. So I have 4x squared minus 2x over h. Okay, so direct substitution is not going to work. So FOIL this out, distribute a 4, and I'm going to rip through this thing. So I have a 4x squared plus an 8xh plus a 4h squared minus 2x minus 2h minus 4x squared minus 2x plus 2x, sorry, all over h. And again, I'm taking the limit as h goes to 0. Holy cow, I'm not going to have time. All right, we're going to have a really short third video. But basically what this looks like is this. I want h to approach 0, which means I'm asking you for points that are so close together that when I subtract x2 from x1, my answer will effectively be 0.